Shattering assumptions. Best of breed block performance, best of breed file performance, best of breed object performance. All in one unified platform that delivers industry-leading performance density across each data type simultaneously. Shattering records. Consistent, predictable, scalable, high-performance storage that is shattering performance records. Shattering expectations. Highest performance, highest throughput, lowest latency, highest performance density storage solution with a surprisingly affordable acquisition cost that is easy to manage, consumes less power, all while accelerating your applications. Do more, spend less. Shatter expectations with Pavilion.
I'd like to thank you for joining us today for the webinar on achieving superior high-performance computing through NVMe-oF. My name is Keith Parker, and I'm the Director of Product Marketing here at Pavilion. And today we're joined by Costa Hasapopoulos, our Chief Field Technology Officer and Vice President of Worldwide Alliances.
Hey, Keith, happy to be here today.
Today we're going to talk about how NVMe-oF is being used in high-performance computing environments. Both NVMe and NVMe-oF, and I do want to distinguish between the two, are really enabling government agencies, research labs, universities, and even film studios and other organizations that use parallel file systems to do, and I hate to say more than they ever thought possible because it's a little bit of a cliche, but to really shatter expectations for what they can do in terms of how fast they can move data, how much data they can move, how much they can store in a given footprint, and even what that storage is going to cost. So before we get into what NVMe-oF is and what it can do, let's begin by looking at where we are and how we got here. When we look at the different technologies, we can see that there's been a clear evolution in terms of compute and networking. CPUs have continued to follow Moore's law and have evolved from single core processors to dual socket systems, then quad socket, and all the way up to today's rack scale data centers, where parallel file systems are enabling, in some cases, thousands of systems to work in parallel to power applications. On the network side, there's been a similar evolution. You got old guys like me that remember connecting over a shared network using a 10 megabit hub, and then thankfully moving to switch-based systems with speeds that evolved first to 100 megabit, then 1 gigabit, 10 gigabit, and now 100 gigabit with 200 gigabit on the horizon. But what about storage? Storage has not gone through a similar evolution. Sure, there have been some changes that have gone on to the drive interfaces in the media as we move from SCSI hard drives, SAS-based disks, then to SAS SDs, and now NVMe SSDs. But the fundamental underlying architecture of the latest all-flash arrays today is exactly the same as the architecture we'd find in a SAS array from 10 years ago or a SCSI array from 20 years ago. I started my career way too long ago at Adaptec selling SCSI cards for Windows 3.1 systems. And the very first external array I saw there was based upon the exact same architecture you'd find in 90% of the all-flash arrays available on the market today. And that's really the problem. So if everything is evolving except storage, what have organizations had to do to deal with all the changes that have been going on in networking and compute? I mean, if those systems keep getting faster, storage must do something to try and keep up, right? Well, there've really been two different ways that organizations have dealt with the lack of evolution in storage arrays. First, they've built up a Frankenstein-like collection of different tools that they might have. They might have their databases running on an all-flash SAN, which in turn might tear off to some SAS or disk arrays. Then they might have some NAS systems that handle their file serving and maybe even some direct attach solutions. They probably seek the best of breed solutions for each of these as they try to optimize their performance, but the result is they've got this hodgepodge of different systems, different interfaces, and so on, and it really just creates a management nightmare. Now, the other thing we see, and these are by no means mutually exclusive, would be to have some form of software-defined or maybe a hyper-converged solution. Now, these types of solutions can be good for overcoming some of the performance and latency limitations that are imposed by legacy SAN technologies, but they come with a whole new list of drawbacks. First, these solutions can be difficult to manage. They're easy at first, but as they get larger and larger, management does become a problem. And speaking of scale, when you need to add a resource, be it storage capacity or compute or system memory or whatever, you're not going to just add that resource. You're going to add a whole new, or in some cases, several whole new servers, the addition of which will then require additional memory and processing power to run the software that keeps the whole thing going. And finally, there's performance, which is the whole reason you would move to this model in the first place. Now, performance of one of these nodes can be amazing. If the data requested is stored on the node accessing it, responses can be nearly instantaneous with virtually no latency. The problem is the data requested is not always on the node making the request. In fact, it often isn't. And if that means the request has to be fulfilled by another node in the system, that will not be nearly as fast. The point is that performance is unpredictable. And if there's one thing that latency sensitive applications don't like, it is unpredictable performance. And that's where we are today. And with that, I'd now like to introduce you to Costa Hasapopoulos, who will help us walk through really how all the changes and all the things that have been done to make storage effective today, despite the lack of evolution, how they've really reached their limits and how the changes in the marketplace are really driving the need for a new type of solution. And with that, I'd like to introduce you to Costa. Costa, welcome.
Thank you, Keith. Good backdrop of the history and what is driving the evolution of this new wave of storage. And I think what we see really is the market is really driving this need for flexibility as the market or the customer's world is basically evolving, right? If you think about what, Keith, you had mentioned was people are looking for consistent, predictable, scalable, high performance at low latency. Well, that's being driven fundamentally by applications that are effectively scale out applications. The new generation of applications run on multiple servers at the same time, horizontally to each other. Or if you're using a scale-out infrastructure like a VMware or a Microsoft Azure or a Kubernetes Docker environment, the infrastructure is fundamentally scaling out horizontally. We like to think of that as hyper-parallel infrastructure. Those scale-out applications are hyper-parallel applications. Well, since the infrastructure is scaling, the applications are scaling. What that means is the servers have to scale out horizontally, which is hyperparallel servers. Well, the question then makes sense, kind of what you alluded to, Keith, is, well, shouldn't the storage also scale out? Or shouldn't the storage be hyperparallel? What we mean by that is things that are multiple controllers, high bandwidth, modern protocols, things that you can start small and grow big. We like to think that our storage gives you the performance of DAS or direct attached storage with all the benefits of shared.
That all sounds really good, Costa, but what does it all really mean? We spoke about how there hasn't been a lot of change in storage, so I'd like to talk a little bit about what Pavilion can actually do. I mean, every AFA has NVMe and every array vendor claims to be the best. If you look at any of the vendors' websites, they all talk about how their product is the best, the fastest, the greatest, because they all picked some particular way of framing their product, of segmenting it, so they appear to be better than anyone else. So my question is twofold. First, is there actually a real quantifiable way to compare products across different vendors? How do I compare the 2 racks of storage from one vendor to the half a rack of another vendor to the 4U box from Pavilion? And if there is a fair unit of measure that I can compare them between, how does Pavilion really compare to the competition?
That's a good question, Keith. I joined the company back in March and, I've had a long, tenure in the storage business and doing my own research like you. I read, this vendor, fastest NVMe storage, that vendor, the fastest, And again, like you said, if we're all using the same pieces and parts, well, how is it that one can be materially different than the other, right? And so what I'm going to show you in a minute, Keith, is this concept of let's measure our performance, right? And relative to the competition, whether that's block, file, or object. And then you make an excellent point. Well, how do you normalize something? Well, one vendor may do 15 million IOPS, but it takes 2 full racks of storage to do that. The next vendor like us takes 4 rack units, right? Whether that's block or file object, the concept is the same. So what we're doing in this analysis is say, let's do a running race. Block, file, and object. How does Pavilion compare? What are our performance numbers? And then look at relative to some of the competition. And then in that competition, since they're physically different sizes, let's normalize that on a per rack unit basis. So whatever performance numbers they have, and if it takes them 4U, you divide those by 4. If it takes them 6U, you divide it by 6. And so we can kind of look at what do you get per rack unit, more of that performance density. So Keith, let's just build upon what we just talked about of how we're going to compare ourselves to the competition and how we make that relativeness in the marketplace. And really what we believe, what our architecture, our fundamental architecture is in enabling some super high performance and ultra low latency. Let's put that in context of what we can do and relative to what the competition is, right? And then normalize that on a per rack unit basis to get that performance density. So when we look at a Pavilion box, we can do in the same 4RU form factor, we can either do block, file, or object, or any combination of those. And as we talk about, and Keith, you mentioned, it's really important in the market is predictable, consistent, scalable high performance, right? Not just high performance, not just consistent, not just scalable, all of those things together at very good latency. So when we look at our world, we're going to talk block, file, or object. In every one of these use cases, it all is in our 4 rack unit box with 1 petabyte of usable storage. So that's protected after RAID, right? So all the overhead of what you'll say overhead of RAID is already built into our numbers. So when we look at our performance from a block perspective, then we'll continue on with file and object, is our read performance, Keith, is 120 gigabytes a second read, 20 million IOPS at 100 microsecond latency. Our write performance is equally as impressive, 90 gigabytes a second, 5 million IOPS at 25 microsecond latency. Well, yes, on paper, those look like, really good numbers, but let's put it in context to the competition. And in this case, I'm not going to talk about the names of the competition. These are numbers on their published website, right, that they're putting out as market-leading numbers. One of them publishes 15 million IOPS and 350 gigabytes a second read. Wow, that's more read performance than us, but that's in 80 rack units. 80 rack units is 2 physical racks. Somebody else has over 11.4 million IOPS and over 300 gigabytes a second read. But again, that's in 48 rack units and actually takes 12 of their boxes, clustered together. Another one of the competition doesn't talk about their IOPS, but is publicly knowledge out in the marketplace about 600K IOPS, and they do 32K IOPS. The 2 and above are 4K IOPS, which is the industry standard to represent your numbers. But theirs is 18 gigabytes a second read. Don't publish their write, but they do publish and brag about their latency, 150 microseconds to 1 millisecond. Ours is 100 micro to 25 microsecond. So when you look at that, that's really about a 9 rack unit form factor. So when you look at that and put it relative to the competition, depends on who you're comparing to below. From an IOPS, we're either 7 to 50 times the IOPS per rack unit, 7 to 10 times the gigabytes per second read, or 2 to 7 times the capacity per rack unit. Keith, it just doesn't end with block. Let's turn our numbers over to file in our NFS world. Our performance numbers are 90 gigabytes a second read and 56 gigabytes a second write. Again, let's look at the competition. One of them is 15 gigabytes a second read, 4.5 write, in the same 4 rack unit form factor of us, but half the physical capacity. Remember, another one of the very big leaders in the NFS space, 15 gigabytes a second read. They don't publish their writes. Again, about the same physical size and physical capacity. But performance depends on which number you look at. What is that, 5 times less read performance than us? There's another player out there that's getting a lot of press, talks about their big capacity and all this, and they do 20 gigabytes a second read and really takes about 6 rack units to deliver that. So when you normalize us against the competition, Keith, again, per rack unit, 6 to 7 times the read, 12 times the write, and similar or double the capacity. Depends on which lens you look at. Again, up at the top from a performance and block and file, but it doesn't stop there. Our new object protocol, we do 80 gigabytes a second read, 35 gigabytes a second write. Look at the competition, 14 and 4. Kind of an interesting one here. One of them publishes a terabit per second write. Well, terabit per second write equals 171 gigabytes a second write. You could say, oh, that's quite a bit more than a Pavilion box that only does 35. Yes, that number's right. That's 704 rack units to deliver that, Keith. Keith, that's 352 physical servers. That's 17 racks of servers to deliver 171 gigabytes a second write. If we want to do that, we just put, what is that, 5 of our boxes in 20 rack units, in half a rack. So when you look at the per rack unit, we're either 3 to 6 times the read, about 8, almost 9 times the write, and similar 1 to 2 times the capacity. So Keith, again, whether you look at the numbers, if we're all using NVMe, we're all using Intel servers inside, CPUs inside this thing, we're all using some sort of the same networking, how is it that we have such materially different performance and impressive throughput, IOPS, as well as latency? Like I said, if we're all using the same stuff, how can we be so materially different? And so what I've kind of put together is really kind of a block diagram. If you think of a typical storage array, they all have a bunch of SSDs or spinning disks, whatever it happens to be. They have some sort of internal bandwidth that connects to the controllers, typically 2 controllers. They have some ports that connect out, leveraging some sort of protocol. And then internally, through the software out to the host, there's some sort of data queue all the way back to the drive, right? And the sum of total of this, there's some software that runs all this stuff together. Effectively, that's a storage array, and it delivers some IOPS, some read throughput, and some write throughput. That's the history of storage arrays. So what did Pavilion do differently than the competition, right? So let's look at this. The first thing what people did was some people replaced the NVMe drives with NVMe SSDs. That's great. They're materially more performant than a regular SSD, and they got some sort of bump. But again, the architecture all inside the box stayed the same. Some people added NVMe over Fabric. Not all of them did that. Some people did. Some added fiber channel, some added IP. And the importance of doing IP, NVMe over Fabric with Ethernet or InfiniBand, is you get RDMA, which reduces your latency, right? But so some people did added some sort of modern protocol. But the real question is, what did they do in between? Keith, they had the same bandwidth. They have the same 2 controllers. They have the same number of ports. But their drives are 4 and 8 and 10 times the throughput of what they had before. What did they do with their data management software? What did they do differently, right? Well, one of the reasons how we have materially, got such better performance than the competition, we started with hardware and software specifically designed for NVMe and NVMe over Fabric, all the way from the host right down to the drive, right? The end result, as I said earlier, is 20 million IOPS, 120 gigabytes a second, 90 gigabytes, this ultra low 25 to 100 microsecond latency, right? So yes, we started with those NVMe drives, but we have 72 NVMe drives with 4 queues per drive. We have a 6.4 terabit per second backplane connecting to not 2 controllers, 20, up to 20 independent controllers. We can have up to 40 100 gigabit Ethernet or InfiniBand ports. And we've added NVMe over Fabric, whether that's InfiniBand or Ethernet, whether that's TCP or Rocky, as well as now we support NFS and S3. And so with our unique solution with NVMe over Fabric, we get multiple queues through every one of those protocols, leveraging NVMe over Fabric all the way down to each one of the drives. We then took software built from the ground up specifically to only support NVMe and our hardware architecture. So very light software, modern built with modern technology, modern software, and we added other protocols on top of that. So fundamentally, we're built from the ground up to support NVMe and NVMe over Fabric, not just new drives inside our existing architecture.
Okay, so that makes sense. So Pavilion broke away from the old legacy hard drive dual controller architecture and moved to more of a switch-based architecture to take advantage of the multiple controllers that are in the array. I get it. That makes sense. But I also have to ask, what would someone do with all that performance? Does everyone really need 120 gigabytes per second of performance or 25 microseconds of latency? What if I have different workloads and maybe I need that kind of performance, say, for my SQL server? Maybe I have a database for which I need really great performance. But I also have all the other usual stuff. I've got file shares and so forth. Normally, I would never have these on the same system. Even if my system supported unstructured data for my SQL workloads and NFS for my file shares, running both of those on the same system has typically been, well, let's say non-optimal. So how does Pavilion handle that?
That's a good question, Keith. And when I first joined again, I kind of go these stories. I'm reaching out all to my industry contacts, and there was a pretty well-known industry analyst I was speaking with, who's a friend of mine, and he's like, "What the, what are you going to guys do with 20 million IOPS in 4 rack units?" It's a legitimate question, right? And so I think the thing what I'll show you in a minute, Keith, is you don't have to start with 20 million IOPS is the first thing. You can start small or start smart and grow into it. The other piece you mentioned, Keith, because we have multiple controllers, disparate workloads can run on each controller and not interfere with each other. NFS doesn't affect your block performance or your S3 performance, right? In fact, one of our customers, Holly, is a public reference for us, on the single platform of our platform, I actually have a couple of them now, they run their entire IT organization on our platform. Whether that's using VMware 7.0 and using NVMe over Fabric, one of the first in the world to run VMware NVMe over Fabric with RDMA, whether it's running just plain NFS for an ERP system or block, they're running Exchange, they're running their time card applications, their ERP systems, all on a single platform, and now they just bought another platform. So disparate workloads. So Keith, I think it's a really unique opportunity we have in our solutions because we have so many different controllers. It's not just about starting small and growing big. It's that disparate workloads on the same controllers. And maybe if you give a minute, I'll share some examples of how you could start smart and grow bigger, leveraging our technology.
That's great. Thank you, Costa.
So that question again is, what would someone do with all that performance, right? Well, first of all, remember we're a hyper-parallel array and we have the flexibility to scale in place. Somebody may buy our storage array, Keith, with maybe 2 of our line cards, which contain 2 controllers each. So that's 4 controllers, and they may be just running block protocols, NVMe over Fabric to those. 1 of our RAID groups with 18 of our drives. So they may start with 2 line cards and 1 RAID group. And over time, they may say, I probably need a little more performance because I want to run NFS, but I have enough capacity. So I don't need any more drives, but I buy more horsepower. Later on, I may need more capacity for some other applications running on those protocols. Or I may, again, want to now start running object on other performance and other line cards, right? But I still have the same capacity, right? Again, you get the gist. I can control performance and capacity independently of each other. So I may start small and put it air quotes of only 4 million IOPS and scale myself up to 20 million IOPS. I may start with just block and eventually running block, file, and object on the same platform. The whole idea here is we have that ability to linearly scale, that consistent, predictable, high performance with low latency, whether it's block, file, or object. And by the way, these are published numbers. Our numbers for performance are measured at the host, Keith, not at the ingress, egress of the box. Or I actually recently learned, I went to one of our competitors' website, and they said, how many IOPS do they have? And their calculation, Keith, was this. An NVMe drive can do 3.3 gigabytes a second, and we have, I'll pick a number, 100 NVMe drives, so our IOPS is 100 times 3.3. You can't do that. That's the theoretical limit of a drive, not the overall of your system. We publish it all the way out to the host. So Keith, that's one of the things that people can do with all that performance on a Pavilion storage array.
Wow, that sounds really great, Costa. But what kind of applications are people running on Pavilion? What are the applications that can really take advantage of this kind of performance?
That's a good question, Keith. And I think, really it's any application that requires linear scalability and needs that consistent performance. Remember on my first slide, I talk about hyperparallel apps or apps that scale out and run on multiple servers? Well, typically we look at those in really three categories. Things that need, we'll call them big and fast, right? They're your, Lustre databases, the external file systems like Lustre or BGFS or IBM Spectrum Scale, or, some of the applications that are leveraging technology that allows it to run on multiple servers to get high IOPS, low latency. Those applications could be things that we call modern cloud. In other words, the VMwares or the Kubernetes environments that are allowing you to scale your applications horizontally. And those applications, the modern cloud, Keith, is typically being deployed to deploy these new versions of modern apps or the big and fast apps, not to typically run your Oracle Exchange environments, the IT of today. Yeah, of course we could do that, but our use case is where we need consistent, predictable performance as we scale out horizontally. And that really applies into a lot of these other, what we call modern apps, the Green Plums of the world, the Splunks, the Elasticsearch, the new NoSQL databases like Cassandra and MongoDB and all those kind of things. So there's several applications, Keith, that really, a very large percentage of these, when they first came out 3 and 4 years ago, people were deploying them on servers with storage inside the box because they got that ultra low latency and the best performance. But again, through our technology and NVMe over Fabric, we can give that same or similar and actually a lot of times better performance through our external storage array than through actually disks physically inside the servers. Because it also gives you the ability in these worlds here to scale the performance of your apps independently of your storage. Because Keith, you know this, if you deploy direct attached storage, if you need more capacity, guess what? You got to buy more horsepower as well. If you need more horsepower, you got to add more capacity. We allow you to scale that independently because we're divorcing the storage from the actual compute. Hopefully that makes sense, Keith. Give you an example of how somebody could start small and grow big, and what are the use cases of our technology.
Wow, that all sounds really great. But there is one more question I want to ask you. So Pavilion is, give or take an X or two, let's say 10x better performance than the competition, 10x better latency, 10x better density. Are you also 10x the cost?
That's a really good question. I'm going to talk through that on the next slide here. And I'll put a little bit of a story of me personally. So, months ago, I'm getting pitched to come work for Pavilion, right? And a couple, Sundar, one of the founders, and Gurpreet, the CEO, are talking to me about our technology and giving me a similar presentation. And I'm like, holy moly, this is amazing. But in the back of my head is like, okay, it's 5 to 10 times, like you said, 5 to 10 times the performance, but is it 5 to 10 times the cost? Well, actually, coming here and knowing this, I think our price, market price competitive, is cost competitive as any competitor on the market. In fact, I believe when you look at what we provide, we'll actually be cheaper or as cost effective as anybody else in the market at a price per gigabyte perspective. But then when you start to throw in the performance perspective, it's not even a fair fight. But the beauty of this, Keith, is you don't have to start with 20 million IOPS. Here's some examples of this. There are people that are buying 100% of one of our boxes, 20 million IOPS, the whole thing, 4 rack units, 72 drives, a petabyte of usable storage, and of course, by the end of the year, 2 petabytes as 30 terabyte drives come in. We'll call that our performance and capacity optimized. But you know what? There are people that say, I need all that capacity, but I don't need 20 million IOPS. I'll put in air quotes. I only need 8 million IOPS. When you go look at the competition, by the way, I showed you earlier, there was only one other competitor or 2 competitors that have more IOPS than us, right? So 8 million is 2 and 3 and 4 times most of the competition in performance. So we can get capacity optimized. Or there are people that actually start, like I showed earlier, that maybe only need half a box, half the horsepower, half the capacity. Or as I showed earlier, start small, 4 million IOPS, 1 RAID group, up to 250 terabytes. You can start small and grow big. So I think there's a lot of use cases for this, Keith. And at the end of the day, I think we are as price competitive as anybody else in the marketplace, on a dollar per gigabyte perspective. But then you throw in the other factors of floor space, cooling, rack space, performance, all, whether that's IOPS, whether that's, throughput. I don't think it's even a fair fight. But to be fair, Keith, I may be a little bit biased.
Well, that's okay. I'm certainly a little biased myself, but one of the primary tenets of Pavilion is being open, being honest, and that's one of the reasons why you've done such a great job of really kind of leveling the playing field so that everyone can understand how can we really compare to the competition on a fair basis so that everyone gets really the same type of information. And I think that's so important. So thank you again, Costa. This has all been really amazing. Is there anything else you'd like to leave us with?
Yeah, let me just leave you with a few thoughts, Keith. Is back to that question, why does high performance matter? If you think about it from the ground up, it's flexibility and choice. It gives you that consistent, predictable, linear scale performance. Linear is the key word. And that predictability gives you the ability to start small, grow big. There's lots of new workloads that require lots of servers to run horizontally and require that linear scale out performance. Again, benefit of us. They want all the performance of DAS and the benefits of the disk right next to the CPUs that are doing the IOs. Well, if we can give you that same performance with all the benefits of shared for these new modern workloads, performance helps with that. The ability to share your systems with disparate workloads and the ability to grow in place kind of gives you that rack scale design, Keith. You don't have to start with 20 million IOPS, right? You don't have to start with a petabyte, right? You can start small and grow in place non-disruptively and scale your applications. And again, yes, we may be 4, 5, 10 times the performance, 8, 10 times the bandwidth and throughput. But we will be market competitive to other all-flash NVMe arrays. In some cases, all-flash arrays in general without NVMe. Our price per gigabyte is competitive in the marketplace. So don't think expensive when you think us. Think scalable and think the ability to start small and grow big and give that flexibility and choice. And to leave you with something, Keith, is when you think of Pavilion, think that if you need big and fast, we do that really, really well. And that enables that hyperparallelism, right? And what we're really proud of, one of our largest customers, told us this in an email. And it's a quote we use now is, Pavilion makes the impossible possible. With that, Keith, I'll turn it back over to you.
Thank you, Costa. That was very informative. At this point, I would like to open it up to a question and answer session. If any of you do have questions, please feel free to put them into the chat window and we will answer them as quickly as we can. In the meantime, we do have a few questions that have already come in. The first question is, you talk about performance for different workloads, but what if you want to run all of those workloads at the same time?
The question was, can you run more than one application on the platform? I believe that's what the question was, Keith. Is that what you said?
Yes.
Okay.
Yeah, that's correct.
As I mentioned a little bit earlier, is that one of our customers today is running VMware with NVMe over Fabric on a few of the controllers. They're running NFS on a few other ones, and they're also running NVMe over Fabric, just general block protocol for their ERP system. And the answer is you can absolutely run multiple applications on that. And the beauty of our architecture, each one of those protocols has its own controller. We have 20 independent controllers. What we mean independent, Keith, we truly mean their own CPU, their own memory, and their own 200 gig ports, right? And they may be in a form factor of 2 controllers on each one of our what we call line cards. They're independent controllers. So that controller's running block. The next one's running NFS. The next one's running object. And then in fact, on the back end, they may share storage, but our bandwidth in between that and the capacity of the storage far exceeds any of the throughput that any of the controllers could actually do. So there really is no bottleneck between any one of the protocols. So thus you can run multiple protocols at the same time on the same platform. And most all of our customers do that. In fact, we have one in Europe that runs VMware. Today they're running it with NFS. They're on their mode to moving it to NVMe over Fabric on a few controllers. They're running a huge VDI environment. It's like 6,000 or 7,000 VDIs and a couple controllers. They're also running using NVMe over Fabric, some NVIDIA DGX1s, I believe they are, running an analytics application. And they're now deploying Greenplum with VMware on some other controllers, all on the same physical box. So that's a long answer to your question. Yes, Keith.
Okay, well, it was a very good answer. Okay, so the next question is, you talk about having a different architecture than other arrays. Does that mean you're based on proprietary hardware, or do you need some special drivers to run?
Yeah, that's a good question, and the answer is none of what we have is proprietary drivers. In fact, our fundamental software architecture is we believe in the public domain. Actually, we hold 17 patents, and about 10 more are in progression. And one of the patents is called Storage Protocol over Ethernet. Well, the real gist of that is one of the base patents for NVMe over Fabric. So NVMe over a wide area network, or over a network, that patent we've actually agreed to not enforce. And so, in fact, we do everything in the public domain from our software perspective, from a protocol and a lot of things we contribute. But from our architecture, we basically use U.2 drives from many different manufacturers. So the same drives everybody else uses. We use an Intel chip. We use the same memory everybody else does. We use standard Ethernet and InfiniBand ports. Our special sauce is our hardware architecture. We use a PCIe switch in between, again, all off of standard parts. And what our Satish, one of our founders, says is, then we wrote our software to take unfair advantage of the way we configured our hardware. So it's really the packaging of our hardware, which is all off-the-shelf components in a special purpose-built form factor. And then our software is kind of our unique advantage.
Okay, great. All right, and the next question is, you said you do RAID, but I thought erasure coding was better for large disks.
Yeah, I've been around the block in this for a really, really long time. But at the end of the day, we use RAID 6. And what we've found, by the way, is it works incredibly well. And the issue with RAID people had was the rebuild times. In fact, I guess this will be the first time we kind of announced this. We've always said that we can rebuild a terabyte in 5 minutes, right, on our drives. Actually, we just optimized that. I believe it is now a terabyte every 2 minutes. So the RAID rebuild times on our drives are very, very small. So we get all the benefits of RAID without any of the overhead and nervousness of taking, multiple hours and sometimes days to do a RAID rebuild. So if something works really well, let's leverage it. And that's what we do. And we get incredible performance out of our RAID 6 as well, as shown by our published numbers, right? Those are RAID 6 numbers, not RAID 10, right?
Fantastic. Okay, and the next question is, I'm confused. What protocols do you support? Is it Ethernet or Fiber Channel?
We do not support Fiber Channel. We support Ethernet or InfiniBand. And from a physical cabling perspective, right, protocol. And then the software protocols on top of that, we support NVMe over Fabric, NFS, and S3. We support NVMe over Fabric with TCP on Ethernet or Rocky on Ethernet, or of course with InfiniBand, we do that with RDMA. Now some of the competition supports NVMe over Fabric with Fiber Channel, but you do not get any of the RDMA capabilities. Right, so that's how you get that really, really low latency, is through that RDMA. And of course, it helps the throughput too, but it really, really helps the latency. Okay,
great. And see, the last question we have is, would you describe your storage as composable?
Yeah, it's a good question. I think you'll see in a concept, yes, it is, right? And I think you'll see in the future, we'll be doing more and more of that. But a great example of that is our system came out from day one, running NVMe over Fabric, period. Then, through adding software packages on top of each one of our controllers, we were able to add NFS capability. So NFS is running on any one of our controllers if you choose to do that. We then just released our S3 protocol. So now S3 is an application running on each one of our controllers if you enable that. So we are, helping our storage compose itself into other use cases. And I can imagine you can see other things happening in the future with those sort of capabilities.
Thank you very much, Costa. And since I don't see any more questions, I'd like to thank everyone for participating in today's webinar on achieving superior high-performance computing through the use of NVMe-oF. Thank you for attending today's Shattering Expectations webinar. Shatter your own storage expectations. For more information, contact us at info@pavilion.io.